This is part 3 of online lecture 1. In this part, I will discuss the techniques for the production of coherent source. What are coherent sources? If two light waves from two sources are always in phase with each other or have a constant phase difference, then the sources are called coherent source. In the figure 1, B and C are coherent source. The necessary condition for realizing the coherent source in practice are the width of the slit B and C should be comparable to the wavelength of light. The source B and C are equidistant from the source A. That is, the distance AB will be equal to the distance AC. And the slit A and the slit B and C are very close to each other. The interference pattern consists of alternative bright and dark lines or band. These alternative bright and dark bands are known as interference fringes. There are two techniques for realizing the coherent source. Number 1, wavefront splitting. And number 2, amplitude split. Figure 1 shows the method of wavefront splitting for the production of coherent source. In this method, light wave from light wavefront emerging from a narrow slit A is getting incident on the surface of the two parallel slits B and C. So the initial wavefront A is divided into two wavefront. These two part of the same wavefront travel through the different paths and superimpose on each other at a point on the screen to produce the interference pattern. This is known as interference due to division of wavefront. This method is useful only with narrow slit whose width should be comparable to the wavelength of light. For example, Young double-slit experiment, 1 double-slit experiment, 2 double-slit experiment, 3 double-slit experiment, 4 double-slit experiment, 5 double-slit experiment, 6 double-slit experiment, 7 double-slit experiment, 8 double-slit experiment, 9 double-slit experiment, 10 double-slit experiment, 11 double-slit experiment, 12 double-slit experiment, 13 double-slit experiment, 14 double-slit experiment, 15 double-slit experiment, 16 double-slit experiment, 17 double-slit experiment, 18 double-slit experiment, 19 double-slit experiment, 20 double-slit experiment, 21 double-slit experiment, 22 double-slit experiment, 23 double-slit experiment, 24 double-slit experiment, 25 double-slit experiment, 26 double-slit experiment, 27 double-slit experiment, 28 double-slit experiment, 29 double-slit experiment, 30 double-slit experiment, 31 double-slit experiment, 32 Figure 2 shows the method of amplitude splitting for the production of coherent source. This figure shows two medium, the medium 1 of refractive index N1 and medium 2 of refractive index N2. As shown in the figure, the amplitude of the incident wave is divided into two parts as reflected and refracted components at the boundary of the two medium. The refracted part will again be divided into two parts as reflected wave and transmitted wave at the bottom boundary of the two medium. The reflected waves produced from the top and bottom boundaries act as a coherent waves as they produce from the same incident waves. These two parts of the reflected waves travel through different paths and superimpose on each other to produce the interference fringe. This is known as interference due to the division of amplitude. For example, optical elements such as beam splitter, mirror, and the interference in thin film.